As you can see in this second session, looking right over here, most of these are blue slides, so most of this is right from your workbook. I'm just going to lead off with my own little example. Let's talk about where we are. In the previous segment, the first one of this unit, we defined those 6 trig functions. We also looked at evaluating the functions based upon a point. If we knew a point on the terminal side of an angle, and that angle was located with its vertex at the origin and its initial ray along the x-axis, then we could, whoops, I didn't want to put the P there, just a moment. Oh, in fact, I'll change color. How about that? So here's our coordinate plane. We have this angle in standard position, and we have a point right there. Call it P. We know what its coordinates are, and with just that information, we're able to evaluate all the trig functions. So we covered a lot in that first section. Today, we're going to work on just using the knowledge of one trig function for an angle to calculate the other 5. So let's try it for this one. We have a right triangle with 2 sides. If we have a right triangle and we know 2 sides, we can always figure the third side thanks to this Greek mathematician who taught us that if you take one leg of a right triangle and square it, its length that is, and then you take the other length and you square it, that is going to be equal to the hypotenuse squared. In this case, I know what the hypotenuse squared is. It's going to be 36. One of the legs is 5 squared. That's going to be 25. The other leg I don't know. And if I'm going to figure the trig ratios, all 5 of them, then I'm going to need to know what x is. Imagine, I almost forgot to put this square in. That would really give me a bad answer, wouldn't it? So I know that x squared is going to equal 36 minus 25. 36 minus 25. Oh, this is not a satisfying number. All right. 11. I was hoping it'd be a perfect square. I should have done better with my own example. So x is equal to the square root of 11. So right here, we now can put the square root of 11. We can use this information. We were given just 2 of the sides, and we were able to figure out what the third one was. So now I can do all my trig functions. Sine of theta. Remember, it is the opposite over the hypotenuse, or our more recent language, y, if we had this in a coordinate plane, y over r. So 5 over 6. My cosine of theta is the square root of 11 over 6. That's right. Tangent of theta. Now this is going to be the vertical, 5, divided by the horizontal. Something I should have mentioned earlier is in trig, we're not going to rationalize the denominator. It just gets things messy. We know that in algebra we always rationalize the denominator, but in trig, please don't do that. It just makes it so much more confusing. Now we're going to go for the reciprocal partners. In this case, we got cosecant theta cosine's reciprocal partner is secant. And tangents is cotangent theta. So that's my little example emphasizing Pythagoras, which you are going to be using his work a lot. So now let's try using our knowledge of one function to figure out what the others are. Now, we do need to know more than just this one function, because if y is equal to 12 and r is equal to 13, let's see, I better be careful about how I assign the values here. Y equal to 12. Well, let's say that each of these are 3, so I've got a 3 by 3. That would make this 15 and this 15. I'll mark it so we know. My y is equal to 12, which means it's right up here somewhere. And my r is equal to 13. So let me put my point. Oh, I wish it would stop doing that. Put my point right here. I'll make it a big point. So that's a possibility. What's another possibility? If this is 13 and this is 12, another possibility is right over here. That point could be right here. If this is a length of 13 and it's up 12, that could also be the angle. So with just this piece of information, I have two possibilities, both of which are positive. Couldn't be down here or here because those would be negative. This says that theta is in Q1, so that eliminates that possibility. So let me just wipe that one out. That's not a possibility for us. So here's where we are. We're up 12, and all we have to do is figure out what our x is. This is a Pythagorean triplet, so I recognize it. You might not recognize it right off, but we could figure it out by using the Pythagorean theorem. When you square this, you'll get 169, and when you subtract the square of this, let's just write it out, x squared plus y squared equals r squared. So put the numbers in. This is the one you're going to have to find. You're going to end up subtracting y squared from r squared. You'll have 25 when you subtract 144 from 169. Square root of that is 5. So with this, we can do all our functions, can't we? We're only being asked here in this example to find the cosine of theta. Cosine of theta in this quadrant, the first quadrant, all of these are positive. The cosine of theta will be 5 over 13. The tangent of theta will be y over x, 12 over 5. So we only had the value for sine, but we also were told which quadrant we needed to be in. Without that, we wouldn't have known whether cosine was positive or negative. We wouldn't have known whether tangent was positive or negative. Let's try another. If cosine is 2 over 3, that tells us we know what x is. X is 2. And we know that r is 3. Y we're going to have to figure out. So, since cosine is positive, we could be talking about this quadrant or this quadrant. However, we are given the additional information, thank goodness, that tells us we need to place it in this quadrant here. Let's do the Pythagorean theorem to figure this out. We get 2 squared, which is 4, plus y squared, which we need to learn, 3 squared, which is 9. So, y squared equals 9 minus 4, 5. So y is the square root of 5. Now if I'm going to draw a picture of that, I better know what the decimal equivalent is. Turn this on. Square root of 5, 2.2. Okay, that's just for 2.2 so that I can graph it a little more accurately. I'm going to consider these as 1 by 1 grids. You don't have to mark it if it's 1 by 1. You only have to mark it if it's something other than that, like we had over here. So x, when x is 2, y is 2.2. So right about there, wouldn't you say? Okay. So here's our theta right here. And we're trying to find sine. Sine theta. Oh, what did I do? I put it in the wrong place, didn't I? I went ahead and put it in the first quadrant. It doesn't belong in the first quadrant. One of the things we know when we take the square root, there's actually plus or minus. And so this one, it turns out, because we're in the fourth quadrant, is a negative square root of 5. I should have been a little more careful about that. So I've got a negative 2.2 when I convert that into decimal. X is 2, y is right here. Someplace right about there. So I've got I don't know, this could be my theta. I don't know what theta is here. But I can figure out what the sine is. The sine of theta is going to be negative square root of 5. I almost blew that, didn't I? Over 3. And the tangent of theta, that was so close. It's easy for me to forget where I am, I guess. Tangent of theta is going to be a negative square root of 5 divided by x, which is 2. All right, coming down. Let me hold this down. We see things a little better. If tangent theta is 3, well, we're going to have to read that as 3 over 1, because remember, we're always thinking about this as a ratio. And we see that it's positive, so it's either here or it's here. In this case, we're told theta's in the third quadrant, so we know we're here. Let's hope I don't do anything stupid with this one. All right, I know that my x is 1, because for tangent, what's in the denominator is my x. My y is 3. Now if I square both of these and then add it together, the Pythagorean theorem, 1 squared is 1, 3 squared is 9, so my r squared is 10. So r is the square root of 10. So how would I graph that? Well, I've got if I went with this, I would be in the wrong quadrant, wouldn't I? I'd be in the first quadrant. So how can I explain getting into the third quadrant with a 3? It's easy enough, isn't it? If this were negative 3, and this were negative 1, I'd have it, wouldn't I? So that's what it is. It's a negative 1 and a negative 3. So x is negative 1, y is negative 3. Here I am, right there. So let me draw my angle. What would cosine theta be here? It would be negative 1 over the square root of 10. And what would cosecant be? Well, remember that cosecant is the reciprocal partner of sine, right? Sine is y over r, so cosecant theta is r over y. So cosecant theta equals the square root of 10, that's my r, divided by negative 3, so that's going to be negative. Oh, that was a great one, and I was able to keep myself aware that I had to go into this quadrant. That is tricky. So when they're both negative, it turns out that the tangent ratio is going to be positive because you have the negative in the numerator and the denominator. Very tricky. Okay, how about this one? If cosecant we're just talking about it here, is 6 over 5. That means it's positive. Where is cosecant positive? It's positive everywhere that sine is positive. So right here and here. Did I leave out some information? Because I don't think we have enough information here, do you? Just a moment, you hear some rustling of papers in the background. Just looking at the workbook that I copied this stuff from. Let's see if I left something out. I should already have been open to that page. It's awful when it turns out that I'm not as well organized as I should be. What a bad example I am to my students. Okay. Well, let's go forward with this. Actually, no more information was given on D. Maybe that's a problem. I think it might be. Okay, so I know what my R is. My R is 6, correct? Because with cosecant, the numerator is R. My Y is 5. But is my X positive or negative? I don't know. That's all right. I can figure it both ways, can't I? We can do it that way. Okay. So let's use the Pythagorean theorem. We've got x squared plus 25 equals 36. So x squared equals 11, right? So x is equal to either plus or minus 11, and we have no way of knowing which. So let's draw that picture. Oh, what will the square root of 11 be equal to in decimal? That's one I certainly haven't memorized. I know it's going to be greater than 3 because square root of 9 is 3. Okay, 3.3. That's good. So this is equivalent to plus or minus 3.3. So I can draw it. It's either can I draw it? I guess I can. Because if this is 5, I'm still good. And I only have to go over 3.3. So I'm right about here and up 5. So this is where the point might be. The other place it might be, isn't this crazy? We don't really know, is right here. So we've either got, I better use 2 colors, huh? We've either got this angle here, or I've got this angle here. Either one is possible because both of these angles would have a cosecant of 6 over 5. So cosine theta is going to be plus or minus the square root of 11 over 6. And the cotangent of theta, how is that defined? That's x over y, right? And that's got to be plus or minus the square root of 11 over 5. Very tricky. I wonder if he ever realized how important that work was that he was doing. How could he possibly have known? Okay, we're going to start with example 4. In what quadrant are we located? If sine of theta is positive, we could be either here or here. True? And cosine of theta is negative. Well, they're all positive here, so we must be in quadrant 2. Secant, let me think for a minute. What's a reciprocal partner of secant? I just think it's so much easier. They match, with regard to sine. So if this one's negative, cosine is negative. And just remember that so much better. Cosine is negative here and here. And tangent theta and cotangent theta are negative. Tangent theta is negative here and here. So we are talking about quadrant 2. Okay. Cosecant, which its reciprocal is sine theta. So where is sine theta negative? All positive here, and sine, of course, and cosecant are positive here. So we're talking about negatives. It's either here or here. Cosine theta is positive. Cosine is positive here and here. So we're talking about quadrant 4. All trig functions are negative. What? Where would that happen? Yeah, it's a trick. All trig functions are positive here, but over here, so let me write that down. All positive here. And what's positive over here? Now this is where I'm asking you to remember that all St. Thomas cousins. So sine and cosecant are positive here. All St. Thomas, oh yes, tangent and its reciprocal partner, cotangent, are positive here. All St. Thomas cousins, oh yes, cosine and secant, its reciprocal partner, are positive here. So where does it occur that all trig functions are negative? Nowhere. This doesn't happen. There is no quadrant where that's true. Trig functions of quadrant angles. Oh, we haven't talked about this at all. It's so important. We have been talking about trig functions for angles that are between the quadrant lines. Maybe they're falling in here, or here, or here. What if they actually fall right on the quadrant? That's what we're going to look at right now. The picture below shows quadrant angles. That's what we're talking about here. Choose a point for each quadrant angle, determine x, y, and r, and determine all 6 trig functions for those angles. Note that the angles can be in degrees or in radians. In fact, I show them here in degrees And in radians, 90 degrees and pi over 2 are exactly the same angle measure. This is the one we're most familiar with. 180 is exactly the same as 180 degrees is exactly the same as pi radians. Okay, I think we got those straight. So, at angle 0 degrees, which is right here, the point we're going to look at is 1 for our x and 0 for our y. So x is equal to 1, y is equal to 0, and what is r equal to? It's equal to 1, isn't it? These are nice. So the sine of 0 degrees, y over r, 0 over 1, is 0. Cosine of 0 degrees, that's going to be one over 1, right? 1 over 1. How about tangent of 0 degrees? That's going to be y divided by x. So that's 0 over 1. That will be 0. Now we'll do the reciprocals. In this case, we'll have 1 divided by 0. Terrible! No! Never! We don't allow that! Never! Oh, no, 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 no. No. So, whew. Of course not. So this one, we can never divide by 0. So we're going to say this one is undefined. This one, 1 over 1, is simply going to be 1. And this one, we have exactly the same situation we had up here. We're going to have 1 over 0. That's undefined. We never allow ourselves to try to divide by 0. So look at that. You're going to run into situations where a trig function cannot be defined. That situation is when the denominator is 0. Let's try 90 degrees. For 90 degrees, this is the point we're interested in. Our x is 0, our y is 1, and again, the radius is 1. It's so easy to figure here, isn't it? Okay, so we've got 1 over 1. The sine of 90 degrees is 1. For cosine, it's x over r. 0 divided by 1 is 0. And for tangent, it's y divided... no! Undefined. Now we're going to do the reciprocals. The reciprocal of 1 is 1. The reciprocal of 0, no such animal. However, the reciprocal of undefined, and what was that actually? Tangent, it was 1 over 0 becomes 0 over 1. That's okay, right? That's a 0. So we've done 2 of our quadrant angles. We've got 0 degrees behind us. We've done 90. Guess what else we're going to do? That's right. We're going to keep going with these. Okay, the trig functions for 180 degrees where our... oh, this is interesting. Now we're into some negatives. Very good. So our x is a negative 1, and our y is 0, and r is 1. Right? Remember that r, the radius, is always positive. Doesn't take on a direction. Okay, so now the sine is 0, divided by 1. That's 0. Cosine is negative 1 divided by 1. So that's going to be negative 1. Tangent is going to be 0 divided by negative 1, so it's negative 0. No, we don't say negative 0, just say plain old 0. Now we're going to do the reciprocal, and what do we notice here? Can't take the reciprocal of this. And this has got to be undefined. And what about this one? Can we take the reciprocal of negative 1? We sure can. It's negative 1. Can we take the reciprocal of 0? We cannot. It's undefined. 270. All right. Or 3 pi divided by 2. I should be mentioning that. There is our x and our y for this. So our x is 0, our y is negative 1, and r, as always, 1. Okay, so the sign y over r is going to be negative 1. The cosine x over r is going to be 0. Tangent y, oops, undefined. Cosecant is the reciprocal of this, is still negative 1. Reciprocal of 0 is undefined. Reciprocal of undefined is a 0. Is that interesting? Okay, see you back in class. We'll do these two in class tomorrow, and or whenever we meet next, and answer any questions you may have. This was a nice lesson.